Let us solve for real number x comma y such that 16 to the power x square plus y plus 16 to the power y square plus x is exactly equal to 1. So we want to solve this equation. Observe that we can take x equal to 0 and maybe we will be able to solve for y, and maybe we can take x equal to 1 and again solve for y. So we might expect that since x and y are independent, this equation has got a large number of solutions. But that does not happen. The reason being 16 to the power x square plus y plus 16 to the power y square plus x turns out to be much bigger than 1, and so the equality will not be maintained in most of the cases. In fact, we will get very few number of solutions. Let's see. So let's write the equation once again. 16 to the power x square plus y plus 16 to the power y square plus x equal to 1. As we said, we expect that 16 to the power x square plus y plus 16 to the power y square plus x is definitely bigger than 1 in most of the cases. In order to prove it, we'll need something called AMGM inequality or arithmetic mean geometric mean inequality. If a and b are two real numbers greater than 0 or even equal to 0, then a plus b by 2 is definitely greater than or equal to square root of ab. A plus b by 2 is arithmetic mean of a and b, and root ab is geometric mean of a and b. So arithmetic mean will always be greater than or equal to geometric mean. For positive real number a and b, this can simply be written as a plus b is greater than or equal to 2 times root ab for any two positive real numbers a and b. Observe that 16 to the power x square plus y, that's a positive real number. 16 to the power y square plus x is also a positive real number. So by AMGM inequality or arithmetic mean geometric mean inequality, 16 to the power x square plus y plus 16 to the power y square plus x is greater than or equal to a plus b is greater than or equal to 2 times root over ab. So 16 to the power x square plus y times 16 to the power y square plus x. Now we got the same base 16, so we can add the power. So in fact these two are equal, so we just write greater than or equal to 16 to the power x square plus x plus y square plus y. Now as I said earlier, somehow we want to show that this quantity is greater than 1 for most of the cases. In order to do so, we consider the power x square plus x plus y square plus y, and let's try to write it as a perfect square. However, x square plus x plus y square plus y, somehow we'll want to write it as a perfect square. X square plus x can be written as x square plus 2 times x times 1 by 2. So if we want to render it to be a perfect square, so just add 1 by 2 square. What about this one? Y square plus 2 times y times 1 by 2 plus 1 by 2 square. Now 1 by 2 square is 1 by 4, but we have to maintain the equality. First of all, let's write it. However, x square plus x plus y square plus y equal to this expression. No, not equal, right? We are adding 1 by 4. We are adding 1 by 4. So in order to maintain the equality, I have to subtract 1 by 4 and then subtract 1 by 4. Yes, we are maintaining the inequality, or we are maintaining the equality. So this is equal to x plus half whole thing square plus y plus half whole thing square minus 1/4 and minus 1/4. That gives us simply minus half. Now you see that x plus half is most of the time greater than 0 or even equal to 0. Y plus half is also greater than 0 or maybe sometime equal to 0. When is it that x plus half is equal to 0? If x equal to minus half. So if I take x different from minus half, then this quantity is greater than 0, or even if I take y different from minus half, then this quantity is different from 0. So if I take x different from minus half, or if I take y different from minus half, x square plus x plus y square, so x square plus x plus y square plus y is greater than minus half if x is different from minus half or y is different from minus half. Therefore, we want to somehow conclude that 16 to the power x square plus y plus 16 to the power y square plus x is greater than 1. So let's write this as inequality 1. Therefore, by inequality 1, 16 to the power x square plus y plus 16 to the power y square plus x is greater than, by inequality 1 we got 2 times root over 16 to the power x square plus x plus 16 to the power y square plus y, and x square plus x plus y square plus y turns out to be greater than minus half. So 16 to the power minus half. Now we can write 16 as 2 to the power 4. So 2 times 2 to the power 4 times minus half. 4 and 2 can be cancelled. So this turns out to be just 1. So we see that if x is different from minus 1, or if y is different from minus 1, if x is different from minus 1 or y is different from minus 1, 16 to the power x square plus y plus 16 to the power y square plus x will not turn out to be equal to 1. In fact, it will turn out to be greater than 1. What if x equal to minus half and y equal to minus half? For x equal to y equal to minus half, 16 to the power x square plus y plus 16 to the power y square plus x minus half square is plus 1/4 and y is minus half, plus 16 to the power y square is plus 1/4 minus half. Half minus 1/4 is 1/4, but we have to write minus 1/4, and then 16 to the power minus 1/4 because minus half is bigger. Now 16 can be written as 2 to the power 4, and 4 and 4 will get cancelled, so we will be left out with 2 to the power minus 1 plus 2 to the power minus 1. That's simply equal to 1. So therefore only solution of the given equation is x equal to y equal to minus half. And so we are done.